Hello, this is Lonnie Russell with EnergyMan LLC, and today I'd like to talk about energy audits for churches, what makes them unique, and some of the common findings that occur. As can be seen in this slide, we've had the privilege of auditing many different types of churches, from historic to contemporary. Let's talk about a few of the things that makes a church energy audit unique compared to a typical commercial energy audit. The schedule, for one, there's limited hours in most churches. Some have schools and work full time, but many just operate maybe 10 hours a week. This makes paybacks on equipment upgrades pretty challenging. Large swings in population. Not every day in a church is Christmas Eve or Easter. There's very big swings in population. Special equipment needs, organs for one, that would be the analog organ, baptism pools, limited budgets. In times of bad economy, churches really feel the pinch because they have a lot more money going out to help people and less money coming in. Many times the church is used as a multi-use facility, sometimes rented, sometimes actually loaned out to organizations such as Weight Watchers, Boy Scouts, AA meetings. And the architecture in a church is not always conducive to energy efficiency. There's always a sanctuary usually has a high ceiling, and there's a very large amount of window area, ornate glass, things of that sort. Typically, a church's largest energy consumer is the HVAC system, so it's always a good place to start. When looking at the HVAC system, you should try to minimize how much the system runs. You should schedule it so it only runs when it's really needed. One of the easiest ways to do that is with programmable thermostats. If you have a larger, more complicated facility, an energy management system might be worth the money. You can actually use remote access, change schedules, and a myriad of other things remotely or even from smartphones. You need to control your access to thermostats, meaning that not everybody should be able to control the thermostat. I've run into situations in churches where there's two thermostats in the sanctuary, one of them in heat mode and one in cool mode, based on whoever was sitting closest to the thermostat. Not a good idea. The system needs to have an override capability, meaning that it needs to have a push button that when you push it, you only get maybe 1 hour of HVAC time. This comes in really handy when other people are using the facility. It keeps them, stops them from leaving the air conditioning on all the time when no one is there. Optimum start is another option that I strongly recommend. And what this does an algorithm-based calculation that determines the best time to start the system so it's ready to go when you've scheduled it to start. Meaning, let's say you want to operate at 8 a.m. in the morning. You want it to be cool when you get there. The system will look at the indoor air temp, the outdoor air temp, and make a calculation to determine when the best time to start the system is, so at 8 o'clock you're ready to go. This avoids people starting the system up at 5 or 6 in the morning so it's ready for them at 8 o'clock, which is a very common thing I run into. Now let's talk a little about where to set the set points, the temperature set points at. ASHRAE has a guideline, actually it's called Standard 55. This states that in the winter, 80% of all people will be happy at temperatures of 68 to 73 degrees Fahrenheit, and in the summer, 73 to 78 degrees Fahrenheit. So a good rule of thumb is 70 heating, 75 cooling. Now, I do believe in these standards. 80% of all people are happy here, but the 20% can be vocal. So good management practice needs to set this solid and make sure it's not deviated from. Non-occupied set points need to be as aggressive as you can get away with. 85 to 90 in the summer, 55 to 60 in the winter. And Optimum Start helps a lot with these because it will automatically calculate when to start up so you don't come into a cold service Sunday morning, which would be the reason that you're not getting aggressive in the first place. This slide shows an excellent example of why it's important to control the thermostats. This was in a large room that is sometimes loaned out to other organizations. In this case, you can see on the thermostat on the left, the temperature is 68 degrees, which is way too cold for summer use. This is a large room, it's probably a 5-ton unit, and the unit was left on continuously, so it will probably run for the full week until somebody catches it the following week. Here are a couple of good examples of thermostat opportunities. If you look at the thermostat on the left, it actually has a case around it, but it's no longer existent. You just see the shell of the case. So anybody can get to this. It is a programmable thermostat, but it is set up in manual and it runs all the time, so it's not doing any good. The thermostat on the right is a manual thermostat. I run into these very frequently, which means that the unit runs all the time. And typically if you go to a programmable thermostat and schedule it, you can reduce costs 30%. As I mentioned earlier, when you have multiple thermostats that are able to be controlled by anyone, you run the risk of running simultaneous heating and cooling, which is the worst situation you can have so far as energy use. Typically in a church, especially if they are up to code, the outside air system is sized for the maximum population in that church. But the sanctuary is not always maximum capacity. Not every day is Christmas Eve or Easter. This means that during those times of low occupancy, the HVAC system is being severely loaded for no reason. One thing I recommend is the use of carbon dioxide sensors to open the outside air dampers only when you really need the outside air. These sensors have gotten much cheaper in the last few years, getting down to even as low as $100. Now you need a motor operated damper for this to work. You need this damper anyway because it should shut the outside air system off whenever the unit is shut down. Otherwise, you'll have outside air leaking into the building at all times. Could cause humidity and mold issues along with higher energy consumption. Obviously, the best places to use this type of system are areas of large population swings, such as the sanctuary or large classrooms, perhaps. You can see in these pictures, outside air dampers are commonly ignored or forgotten about. Here's a couple of examples of one that's stuck closed and one that's stuck open. Wow, just when it was getting interesting, we're going to have to close out part one. Please rejoin us for part two for energy audits for churches.